In this class, now I am going to explain you a dot product or scalar product of vectors. Consider two non-zero vectors A, B. This is the initial point of the vectors. One is moving this side and one more is moving this side. Both are non-zero vectors, and theta is the angle between the vectors. Theta is the angle between the vectors. Then the dot product of these two vectors, A bar dot B bar, which is equal to mod A bar mod B bar cos theta. So this is the definition of dot product of these two vectors. A and B are two non-zero vectors, and theta is the angle between these two vectors. Then A dot B is defined as mod of A bar into mod of B bar cos theta. You know, I comma j comma k are three orthonormal vectors, orthonormal unit vectors. I, j, k are unit vectors whose magnitudes are equal to 1, and these three are mutually perpendicular. I acts along with x-axis, j acts along with the y-axis, k acts along with the z-axis. So you know, angle between the ij is 90 degrees, jk is 90 degrees, and I and k is 90 degrees. See, suppose if you would like to find I dot I, how much is this result? Tell me. I dot I, A and B both are coincident. I means it is a unit vector which acts along the x-axis, you know that. So take the dot product of these two, and whose magnitude, first vector magnitude will be 1 and second vector magnitude is 1, and angle between these two, I and I, both will be coincident. Hence angle between them is 0. If you put theta equal to 0, cos 0, 1. 1. Hence I dot I is equal to how much? 1. In the same manner, j dot j is equal to 1. K dot k is equal to also 1. I hope you have got it. Now find I dot j. I is a unit vector, j is a unit vector. Angle between these two is equal to 90 degrees. Now put here magnitude of A, I, which becomes 1. Apply this formula between these two. Magnitude of B going to be 1 only, J. Angle between these two is 90 degrees. Here put theta 90, cos 90, 0. So here 1 into 0. So magnitude of I 1, magnitude of J 1, angle between these two is 90 degrees, cos 90, 0. So 0 into something, 0. I dot j is 0. Next, j dot k is equal to 0. Now k dot I is also going to be 0. Remember these points also. Why I dot I equal to 1, I explained you here. In the same manner, j dot j 1, k dot k 1, and I dot j, which becomes 0, because angle between these two is 90 degrees. Put here theta 90, cos 90, 0. 0 into something, 0. Now j dot k 0, k dot I 0. Suppose if you take a vector like this, A1I, A2J, A3K, I bar, J bar, K bar, you can. Now let us take one more vector, B bar is given as B1I plus B2J plus B3K. Now students, tell me, find A dot B. A dot B is how much? So just you would have to take the product of these two. You know how to take the product of binomials, trinomials. In the same way, you have to multiply these two. If you multiply this with this, A1, B1 you will get, and I dot I, which becomes 1. And if you multiply this with these two, result will be 0, because I dot j 0, I dot k 0. Next, multiply this with this, j dot I, which becomes 0, j dot j, which becomes 1. So that here A2, B2 will be left. And here multiply this with this. Okay, if you multiply this with this, k dot I, which becomes 0. 0. Now k dot j, which becomes 0. K dot k, which becomes 1. So A3, B3 will be left. Okay, right. Now see students, sometimes this dot product may be positive. If dot product is positive, you know, cos theta is equal to mod A mod B, A dot B by mod A mod B. Otherwise you can write like this, A dot B equal to mod A mod B cos theta. Whenever A dot B is positive, then observe that theta belongs to the first quadrant, means theta is lying between 0 to 90 degrees. Angle between the vectors is an acute angle. And A dot B, sometimes you may get 0. When it is possible, whenever the theta is equal to 90 degrees. So put theta 90, cos 90, 0. Then a dot product will be equal to 0. If A dot, and also here you have to remember, A dot B equal to 0, then theta will be 90 degrees. Sometimes A may be 0 vector, B may be 0 vector. Okay, if A is 0, then magnitude of A is 0, 0 into something 0. If B is 0, magnitude of B is 0, 0 into something 0. Or both may be perpendicular to each other, like this. Perpendicular. In this case, angle between the two vectors is 90 degrees. So dot product of the two vectors is 0, means either A may be 0 vector or B may be 0 vector, or both may be perpendicular vectors. Okay, remember that point. Next, A dot B, if it is negative, then what do you comment? Theta is obtuse angle, because when the theta belongs to the second quadrant, angle between vectors will be 180 degrees, more than 90. You get the diagram like this, more than 90. So more than 90 to less than 180 degrees. Okay students, if the theta A dot B is negative, then you get an obtuse angle. It may be equal to less than or equal also. Okay students, see, sometimes you will get A dot B is equal to magnitude of A magnitude of B. When it will happen? Whenever theta is 0, means both are coincident. A and B, both are coincident vectors. So when this will happen? Whenever theta is 0 degrees, then cos 0, 1. Now A dot B can be written as magnitude of A into magnitude of B. If both are opposite to each other, means here A is moving this side and A bar is this side. This is B bar. Now angle between them is 180 degrees. If you put here theta 180, cos 180 minus 1. Hence A dot B equal to minus of mod A minus of mod B. Okay students, I hope you have understood this. A and B, two vectors are given like this, then A dot B means A1 A2 plus B1 B2 plus A1 B1 plus A2 B2 plus A3 B3 you will get. You may get that the dot product may be positive. If it is positive, theta is acute. If it is 0, then theta will be either 90 degrees, or you may get magnitude of A 0 or magnitude of B 0. If A and B are perpendicular, then dot product is 0, or any one of these two vectors may be null vectors, or both may be null vectors. In such case, you will get dot product 0. If angle between them is obtuse, then dot product will be negative. So suppose if theta is 0, then A dot B can be written as magnitude of A, magnitude of B. If A dot B is equal to minus mod A, mod B, whenever theta is 180 degrees, straight angle between A and B. A is moving this side, B is moving this side. Remember these points. See, if A and B two vectors are given like this, then you can write like this here, A dot B. A dot B, how much have we got? A1, B1 and A2, B2 and A3, B3 by magnitude of A. Square root of A1 square plus A2 square plus A3 square. Root of magnitude of B. B1 square plus B2 square plus B3 square. You know, whenever the two vectors intersects like this, one may be acute and one may be obtuse. You know, vertically opposite angles are equal. If it is theta, this will be theta. This is 180 minus theta. This is also 180 minus theta. Okay, students? I hope you have got it. So suppose if you want only acute angle, just you would have to put modulus symbol here. You know, purpose of modulus. If it is negative, even though it should be taken as positive. Okay, students? See, whenever the two lines intersects like this, if one is acute, then other one is obtuse angle. Unless they intersects 90 degrees to each other. Vector is also a direct line segment. You know that, which we have discussed in the addition of vectors. See, this is the cos theta formula when A and B vectors are given. If theta is 90 degrees, put here theta 90, bring it to the left side. Then you will get A1, B1, A2, B2, A3, B3, which is equal to 0 you will get when theta is 90 degrees. If theta is 90 degrees. Yes. Now R is any one vector, or you can say it as resultant vector. You can take xi, yj, zk. Now this R can be written R dot I into I, R dot j into j, R dot k into k. If you simplify R dot I, here what do you get? Multiply this with I. So you get these two terms will become 0. Then here what is left? X will be left. If you find R dot I, so here you will get X only. R dot j if you do, here you get Y. R dot j, R is resultant vector. You can take like this. And j is a unit vector. Take the dot product of these two. You get Y only. Here Z. Now X into Y, Y into J, Z into K, which becomes R only, na? See this. Next, component vector B on A or component vector A and B. See that this is important in the chapter. See, A, this is B. Now this is A vector, B vector. The projection B on A, you may get this. Let it be okay, M. This OM is the projection of OB. OB means here B vector. Projection of OB on OA is OM. And projection of OA on OB is, see, let it be N. ON is the projection of OA on B. No confusion. Projection, which is nothing but shadow. Okay, the shadow of this B on OA is OM. Your angle between them, you can take theta. Okay, students, OM is what? Projection of, this is the projection of B on A. And ON is what? Projection of A on OB. Shall I give you direct formula or shall I give you whose proof? Okay, proof is not required. Remember, like a standard formula. See here. The vector, component vector. The component vector B on A is B dot A bar by mod A whole square. Remember, like a standard formula. This OM length, this is equal to how much? OM. Or this vector component also can be called as orthogonal projection. Orthogonal projection of B on A is OM in the figure. If you apply this formula, you get that OM length. Okay, students. So, OM vector B dot A bar by mod A whole square. In the same manner, component vector or orthogonal projection A and B. A and B, in that figure ON. ON is equal to here A dot B vector by mod B whole square. What is this? Projection of A on OB in the figure ON. Vectors. Suppose if you want whose magnitude? Magnitude of OM. Now apply mod on both sides so that here you will get B dot A magnitude of A by magnitude of A whole square. You can write magnitude of A, magnitude of A. Both of them cancel. B dot A by mod A. This is the length of OM. In the same manner, apply magnitude for this. So that here you get A dot B mod B by mod B whole square means mod B into mod B. Both of them cancel, which is equal to A dot B by mod A. So this is the length of ON. Okay, students, I hope you have understood this. Component vector B on A is this, whose magnitude is this. This is the component vector or orthogonal projection of A on B is A dot B bar by mod B whole square. Now if you want magnitude, take mod on both sides, simplify. A dot B by mod A you will get. Okay, right. Suppose if you want this vector component or component vector of B in the direction perpendicular to A means BM. Next, what do I want? Projection of B, or you can call it as component vector of B in the direction opposite to A, which means that BM. In the previous one we calculated projection B on A na. Now we want projection this B along with BM. Along with BM means simply you can apply the Pythagoras theorem for this triangle. Here it is 90, no? Apply the Pythagoras theorem. Hypotenuse square means, see, okay, B minus, and this is, how much have we got this? B dot A, magnitude of B whole square or B square you can write. See, B minus B dot A by, so in the down, mod A whole square. Okay, students. So this is the vector, BM vector. So projection of this B in the direction perpendicular to A means BM you want. Now if you want BM, this is the vector. If you want whose magnitude, you have to apply the mod on both sides. Mod of BM is equal to mod B minus, so here you will get A dot B by mod A. In the same manner, okay, projection of this A perpendicular to B means that AN. AN also, how do you get? AN is equal to, students, see here, A minus, what do you get? A dot B, B by mod B whole square. If you apply magnitude on both sides, so that you get mod A bar minus A dot B by mod B. This is the projection of A in the direction perpendicular to B, which means that AN in the figure. Remember this. Yes, I hope you have got it. Now let us go to this standard results, so which are useful while doing the applications. Mod A plus B whole square means same like binomials. These two vectors you have to multiply 2 times, like A bar plus B bar into A bar plus B bar. Just to do the normal multiplication. A with A, mod A whole square. A with B, A dot B you will get. B with A, B dot A, and B with this, mod B whole square. So which is equal to mod A whole square plus mod B whole square. A dot B equal to B dot A. So this dot product, or you can call it as scalar product, because after taking the dot product you will get a scalar. We don't get a vector, no? So that you can call it as a scalar product of vectors also. So this dot product of vectors are commutative. Commutative means A dot B equal to B dot A. Both are equal. So you can add them. A dot B. So mod of A plus B whole square is equal to how much? Mod A square plus mod B square plus 2 into A dot B. In the same manner, if you want the difference, so you can write mod A square mod B square minus 2 into A dot B. So add both of them. If you add both of them, what do you get? Mod of A plus B whole square and mod of A minus B whole square. If you add both of them, this negative part, positive part cancel. Both are like. Take 2 common. Mod A square plus mod B square. Now take the difference of these two. If you take the difference of those two, what do you get? See, A plus B whole square minus A minus B whole square. You will get 4 into A dot B. Okay? Right. These are some standard useful formulas, okay, which helps you while doing the problems. See next, in the 3D. Okay, there is a plane which is moving p units away from the origin. Is r dot n equal to p, where p is the normal vector to the plane. That is the equation of a plane which is moving p units away from the origin, and where n represents the perpendicular vector to the plane, or you can call it as a normal vector to the plane, is r dot n is equal to p. So sometimes if the plane passes through the origin, this length will become 0. R dot n is equal to 0 you will get, where n is a unit normal vector. What is n? It is a perpendicular vector and whose magnitude is 1. You can say it as n represents unit normal vector. Unit normal vector. Okay, right. Next, suppose on the plane there is a one point A given, okay, and that is passes through a plane which is passes through a point A and having a distance p units away from the origin is r minus a dot n, which is equal to p. If any one point on the plane are given, just r minus a you have to take. Okay, students. So what is n here? Unit normal vector r minus a dot n, which is equal to p. If it passes through the origin, p becomes 0. R minus a dot n is equal to 0 you will get. These are the equations of a plane. Maintains a distance p units away from the origin and passes through a point A, and where n is the unit normal vector, remember that. And sometimes see, they will give you one plane equation as ax plus by plus cz plus d equal to 0, and a line is penetrating through the plane. A line is penetrating through the plane like this, whose equation is x minus x1 by L, y minus y1 by M, z minus z1 by N. Okay, now tell me the angle between the plane and the line. See, I can't able to draw exact diagram. This is rough diagram. See, line will penetrate through the plane like this. Now what is the angle between, see, plane and line? You can take it as theta. Okay, students. See, here this is theta. Theta is the angle between, this is normal actually. Normal to the plane will be like this. Okay, line is moving like this. Now I want this angle. Okay, see, normal. What is the angle between the normal and the line? 90 minus theta you will get. Okay, students, this is the plane equation where ABC represents what? DRs of whose normal. You know that. Here what are the DRs of LMN? What are the DRs of this line? LMN. So when the DRs of two lines are given, you know how to find angle between them, which we have learnt in the plane. So cos theta is equal to mod of, so here normal DRs are ABC and a line DRs are LMN. So AL plus BM plus CN by root A square plus B square plus C square root L square plus M square plus L square. So this is the angle between the line and whose normal. But we want angle between the line and the plane. How much is that? 90 minus theta. So replace this theta by 90 minus theta. So cos of 90 minus theta, which is equal to sin theta. Then in place of this write sin theta. Now sin theta is equal to, so see students, here put cos of 90 minus theta. This is the angle between the line and the plane. So sin theta is equal to an plus bm plus cn whole by root a square plus b square plus c square into root l square plus m square plus n square. Use this formula to find angle between the line and the plane. Okay students, suppose if this line is parallel, if this line is parallel to the plane, line DRs are LMN and plane normal DRs are ABC. This line and this plane normal both are 90 degrees to each other. Now, okay, both are, see, this is a line whose DRs are LMN and plane normal DRs are ABC. The plane normal and line both are 90 degrees to each other. Hence, in such case, you will get AL plus BM plus CN is equal to 0. Because here you have to put in the cos theta formula, theta equal to 90, you have to put cos 90 is equal to 0. Hence, you will get this relation. AL plus BM plus CN equal to 0. When this relation will come? Whenever the line and the plane are parallel. Because line DRs are LMN, plane normal DRs are ABC. Both are lines which are 90 degrees to each other. Hence, this relation will come. Suppose if the line is perpendicular, if this line is perpendicular to the plane, then line DRs and plane DRs will be either parallel or coincident. So in such case, you will get A by L plus B by M, which is equal to C by N, you will get. Okay students, whenever the line is perpendicular to the plane, then line and normal of this plane both are parallel. Both are parallel means these coefficients are proportional. Hence you will get A by L which is equal to B by M which is equal to C by N. And in this chapter you have to remember two more points. Okay, angle between any two diagonals of a cube. So this proof was given in my previous classes. You can go through my other videos. You will find whose proof. If you take theta is the angle between any two diagonals of a cube, so you will get cos theta is equal to 1 by 3. Then theta is equal to cos inverse of 1 by 3 is the angle between any two diagonals of a cube. And in a cube, you know, there are 4 diagonals. If you send a line through the cube, that line will make 4 angles with 4 diagonals of a cube. Let us say them alpha, beta, gamma, delta. These are the 4 angles which are made by a line with 4 diagonals of a cube. Then cos square alpha plus cos square beta plus cos square gamma plus cos square delta, which is equal to 4 by 3 you will get. Okay students, alpha, beta, gamma, delta are the angles made by the line with 4 diagonals of a cube. Then cos square alpha plus cos square beta plus cos square gamma plus cos square delta equal to 4 by 3. So this is the concept of this dot product. These conceptual points are very useful to tackle the applications of dot product. I hope you have understood this class. So kindly I am requesting you to subscribe my channel and forward to other people so that my classes reaches to many people. Thank you one and all.